So we're on to chapter 3. Should be good news for some of you. Chapter 3 is exponents and logs, which should be familiar from Algebra 2. And Frank, I know, definitely hit this last year. So the good news is you're going to have a foundation for what we do, but we're going to obviously take it a little bit farther, and we're going to look at more real-world applications of logs. And also, we're going to really kind of get deep into the inverse and how the math works with logs and exponents. So today we are going to look at horizontal and vertical stretches. So on the front of your flipbook, in class we ended up using the calculator to take a couple different functions and transform them in different ways, and then we figured out some patterns. In chapter 1, a lot of you, we learned how to do a horizontal and a vertical shift, and then we learned how to stretch things vertically. And a lot of you were wondering, well, how can we stretch something horizontally? And I said, wait till later in the course, and we've arrived. So now in chapter 3, we're gonna learn how to stretch something horizontally also. So on the front of your flip book, I'm gonna kind of formalize what we did in class. So on the top left, we're gonna look at vertical transformations. We're gonna look at all the different types and how we recognize those. And then on the right side, we will deal with horizontal transformations. And we'll compare and contrast these in order to see if we can find some patterns to make it easier to recognize each one. Okay. So let's deal with vertical first. 3 different ways to change a function. We're going to use the letter K to represent any number. So K will be represented of a number. So 3 different ways to transform something vertically. The first would be K of f of x. The second is negative f of x. And the third is f of x plus k. Now all 3 of these transformations do something different to the graph. The first one, you can think of your k as your A shift. This is your vertical stretch. And your vertical stretch is going to be always by a factor of k. Actually, I'll write it over here. So you can think of this kind of as your A. So if there's a 3 in front, if 3 is k, we'll vertically stretch our graph by a factor of 3. Second one, this negative is a vertical flip. Across the x-axis. And the last one is a vertical shift. You might recall in chapter 1 when we did HK form that k is outside of the parentheses. It will shift the graph up or down. Now horizontal transformation, same thing. K is just going to represent a different number. So now we have 3 different types of transformations. The first one is f of k of x. Second one is f of negative x. And the third one is f of x minus k. Alright, now today we learned that you drop that k inside the parentheses, you get a horizontal stretch. But something different happens here. You are not stretching by k, you're actually stretching by 1 over k. So say your k was 3, you're not going to stretch something by 3, you're going to stretch it by 1/3. So it actually ends up doing the opposite. It ends up compressing it versus stretching it. And same way if your k was 1/2, you're actually going to stretch that by 2 over 1. Now the second one here, this is a horizontal flip. And then the last one is a horizontal shift. So these are the 3 different ways to transform something horizontally, and 3 different ways to shift something or transform something vertically. Now, there's something going on between both forms, and I want to see if you can recognize it. If you look at the vertical transformation, you look where k is. K is always on the outside of the argument. So you can think of it as outside of the parentheses. It is always applying to your output. So with vertical transformations, the k value of the transformation is applied to the output. Now contrasting this to horizontal, if you look at horizontal, the k, or the transformation, is always applied to the input, or what is inside the parentheses. So now you can kind of you can distinguish between the two outputs. If there's something changing outside of the parentheses, you know it's a vertical transformation, and if something's being changed inside the argument or inside the parentheses, you know it's a horizontal. And there's one other thing that's kind of a little bit deeper here with horizontal. You may notice that in the horizontal stretch you're doing 1 over k, and then the horizontal shift you're doing the opposite. Now we're going to look at the algebra to this later, but with your horizontal transformation you're always kind of doing the opposite of what is told, whereas with vertical your stretch is your k, and your k is your shift. You follow it. Here you're doing the opposite with your shift, and your stretch is 1 over k, so you're kind of doing the opposite. This has to do, and we'll look at this later, with the algebra involved here, specifically the order of operations and PEMDAS. Okay, we will come to figure out why this does what it does later, but for now I'm kind of planting that seed, and it'll kind of help you remember that you'll do the opposite with horizontal.